What if I told you that ChatGPT doesn't actually understand anything you say, yet it still gives you answers that sound incredibly human? At the core of ChatGPT is a powerful neural network called a transformer, specifically a decoder-only version. Transformers are designed to handle language efficiently by processing entire sequences at once, rather than word by word. The key mechanism inside is self-attention. This allows the model to evaluate how each word in a sentence relates to every other word, even if they're far apart. Your input goes through multiple layers of multi-head attention, which looks at different relationships between words in parallel, and feed-forward networks, which help build deeper representations of the text. Before any processing happens, your input text is broken down into tokens. These tokens aren't always full words, they can be word parts. For example, the phrase, ChatGPT is smart, might be tokenized into ChatGPT is smart. Each of these tokens is then converted into a vector, a list of numbers that represent the meaning of the token in context. ChatGPT is first trained on huge datasets made up of books, websites, articles, code, and more. This process is called pretraining. The goal of pretraining is to predict the next token in a sequence. This is known as causal language modeling. So, if the model sees the sky is, it learns to predict the next token like blue. To do this, the model uses a loss function called cross-entropy loss, which tells it how wrong its predictions are and adjusts the internal weights, or parameters, to improve. After pre-training, the model is fine-tuned to make it safer and more helpful using a method called reinforcement learning from human feedback, RLHF. Here's how it works. Human reviewers write good answers to sample prompts. The model generates multiple responses. Humans rank those responses from best to worst. A separate reward model learns from those rankings. Finally, the main ChatGPT model is updated using reinforcement learning to prefer answers that get higher rankings. When you type a prompt, ChatGPT tokenizes your text, passes it through its trained transformer layers, and generates tokens one at a time, predicting the most likely next token based on everything it's seen so far. It continues this process until it hits a stopping point, like a punctuation mark, instruction, or a token limit. The model doesn't always pick the most probable next token. That would make responses too repetitive or robotic. Instead, it uses sampling techniques to add variety. This is how ChatGPT can sound both accurate and natural. The intelligence of the model comes from its parameters, the numerical values it learns during training. GPT-3 has 175 billion parameters. GPT-4 has even more, though the exact number hasn't been confirmed publicly. These parameters are what allow the model to remember patterns in grammar, facts, reasoning, and tone. Despite its power, ChatGPT has limitations. It may hallucinate, generate answers that sound right but are false. It can reflect biases from its training data. And it doesn't browse the internet in real time unless tools are added. So while it sounds smart, it's not perfect, and it doesn't know in the human sense. So ChatGPT isn't magic. It's the result of advanced neural networks, massive datasets, and smart training strategies like RLHF. And it all happens, one token at a time.